Okay, now we want to step through the program using the GDB, but before that I want to just remove these printf functions, since you already know how these things work in the low level, except the maybe the last printf in here. Now I save it, exit, use the GCC to recompile it, -o, pointer, hit enter. Just let me make sure that we get some output. Yes, now I want to say GDB and then pointers, break at main, run, set disassembly flavor to Intel. You should know all of these things by now. And then disassemble main in here to see the instructions, the translation of the codes in the main section. Now at first I wanted to give the task of creating the layout or simulating the layout of the stack and memory regarding all these instructions to you, but then I decided, because the pointers might be the most important thing in the C programming languages, so I think it would be better if I create the layout or talk about it deeply for this one myself too. So first I create another terminal and just open a file. Also create the enter the Python interpreter in here. So at first we look at the info registers RBP. Well, this is the current RSP because this instruction hasn't yet been executed. If I say just RSP in here, you could see that they are just the same thing. Now if I say a step I, the sub RSP and 0x10 would get executed and the RSP length would be increased by 10 in hex or 16 in decimal. So I say a step I, have a look at RSP, and as you see it has changed. So first I copy this value, go to this terminal, paste it in here. This is the last RSP or current RBP, and then after 16 bytes we have the new value of the RSP, which is this, and paste it in here. This is the current value of the RSP. If you want to make sure that the difference in here is actually 16 bytes, you could just copy this value, go in the Python interpreter, say int, paste it in here, say 16 to convert it to the base 16, minus int, and now copy the RSP, go here, paste it, remove the 0x, convert it to base 10, hit enter, and the difference is 16 decimal, which is 0x10. So after that we get to the first instruction in here. So everything else would be in a place in here, which is 16 bytes of the space. First it says move the 0x5. Also let me open the pointers.c. You see this is the code, because first we need to move the 0x5 into the a variable. So as you see it says move the 0x5 in a memory address which starts at RBP minus XC. Also I want this 0x5 to be represented using 4 bytes or dword. Therefore we should calculate the RBP minus C. So I go in the Python interpreter and I say this would be 0xc, which is 12. So if I just, and this is RBP, if I hit enter, well, also I want to convert it to the hex. This would be the RBP minus C. Copy this, go in here, and well, this would be RBP minus 12. RBP minus 12. And of course, you know now the difference between these two would only be 4 bytes, because the difference is 4 bytes and the difference in here would be 12 bytes, and the difference between all of that is 16 bytes, right? It's E194 and this is E190, so only 4 bytes we have in here. So what it means is that if we put the 0x5 in here, it means that this memory address E194 would be 0x 0.5, right? This would be 0x5. Then we have, actually let me just show this to you too. Then we have, let me paste it. Then we have E1 93. After that we have E1 90. Actually this goes towards the higher address, sorry, 95, 96, and this would be 97, right? This would be 97. And in here we have just 0x00. In here we have 0x00. In here we have 0x00. If you're not sure about that, let's just go in here and say x1 xb and paste this value. As you see, well, we have 0xff. Let me see if the instruction has been executed. Well, not yet. You say step I. Now have a look at these memory addresses, and you see we have 0x05. If I say 95, it would be 0, 96 would be 0, 97 would be also 0. I don't know about 98, well, it's also 0, but it is some garbage from before. So after that it says, now that you have moved this, I want to change it, because you see RBP minus XC, or this memory address, these 4 bytes in here represent the A variable. So first we put the 0x05 in it, and now we decided to put 0x A in it, which is equivalent to 10 in decimal. So in here this would change to 0x A. If you're not sure, just say step I and then have a look at this 94. You see it has been changed to 0x0A, or I could just say 4xB to see all the 4 bytes. So after that we go to the next instruction, which is this one. If we look at the source code, you see after that we create a pointer and save the address of the A variable inside the pointer. Actually this is the main and the most important part and the purpose of this lecture, because all of the things that we've been discussing, you already know them. So a pointer, you want to save the address of A inside this pointer. What is the address of A? Well, the address of A is just this thing. You see E194 is the beginning address of the A variable. Now in here it says, because we want to move the address of A variable, right? So it says load the effective address using the LEA, load the address of RBP minus XC, which I just told you is this one. Load this address inside the RAX register, because we wanted to assign it somewhere else. Now where? And then it says, now that we have the address of the A variable inside the RAX, I want to move this value inside a place called RBP minus X8 as a cube word, or 8 bytes. Now I want to look at the RBP minus 8. If we have a look in here, and well, this is the RBP minus 8 would be equal to this, right? I want to copy this, go in here and just paste it in here. Well, as you see, E197, then E198. Well, E198, this value I want to add it let me actually just do it, or just plus 8 bytes later, right? So E198, then we have 99, then we have 9A, 9B, 9C, 9D, and 9E, and at last 9F. All of these address would contain the this address in here. So this one, the 7FFF in here, E194, would be saved exactly in these positions as you see in here. And well, after the 9F, you see that we get to A0, which would be this address in here. So you see the last address before the A0 would be just this one. Let me actually just show it to you too. So this address 1 byte before the A0, which is current value of RBP, would be 9F, and from 98 to 9F is just 8 bytes, which contains the address of a variable, which is this one, E194. If you don't believe me, let us just step through it. If I say disassemble main and have a look, we are currently at this address, right? So if I just copy this value and right now have a look at it using the x by saying 8xb in here, paste it and hit enter, you see actually all of them are 0. But if I say step I and then have a look at this address, so no, actually I said, sorry, I should have said 19. Let me just make sure of that. Well, yes, actually FFE198, which would be A0 minus 8. Let me just make sure. We say disassemble main. Well, yes, well, this address has been moved to RAX. Now info registers RAX would be equal to this one, 94. Then we say a step I. Actually, this one should get executed, right? So if I say step I, then disassemble main, we are at this one. Again, we say step I, and now this thing that I told you should happen. If I just execute this again and hit enter, you see we have this value 94 E1, then FF 7F and 2 zeros. And if you look, 94 E194, you see it's in the Little Indian format, is the address of the A variable that we talked about. Also, if you are just concerned with these 20 bytes, you see that this address in here is actually 8 bytes. You see, we are in the 64 architecture. So, but if you look, we have 1 byte, 2 byte, 3 bytes, 4, 5, and 6. So we have 2 zeros at the beginning that we haven't written, and then we have 7F, FF, and then FFE194 or something like that, which would be 8 bytes. Also, because we are in a 64-bit architecture or 8 bytes architecture, therefore the size of the pointer should be equal to 8 bytes, so that we could just address any memory cell that we want. So the reason is just the same thing, that we move the RAX as a keyword or as 8 bytes, and therefore right now we have all the address in here, this address saved in these places at here. So if we wanted to see the address of the pointer, we would get this address. You know what I mean? So let me just go on with the next instructions. Well, after that we have moved the 0xf inside the D word, which is pointing to the RAX. What it means is that it says look at the RAX register. So info registers RAX, right? This is E194, which is actually the address of the A variable. Then it says now move the 0xf inside this one. So if we look, what it says is that remove A and put F in here, which is just related to P is equal to 15 in here. And after that we get to the printf function, which you already know. Move this one into RAX, move the RAX in the RSI, and at last we call the printf in here. I hope I haven't confused you and that it's not boring. If you just pay attention to what I said, it could be so useful. One more thing that I wanted to just tell you is that I want to, in here I want to print something else, or I want to just print the address of the pointer too and have it as another pointer, because we saw in here that this is the address of the pointer. We said that pointer is a placeholder to hold the address of the A variable, right? So the pointer itself has an address. The beginning of the address is this, which is a place for holding the address of the A, and this was the address of the A variable. So in here, if I just save it and say gcc dash and just pointers.c-o and then pointers and hit enter, well, it says we have a problem in here. Yes, we have two commas. If you remove one of them, recompile it, execute it, or let me also provide some forward /n, /n, save it, recompile it, execute it again. So this would be the address of the pointer. This pointer would contain the address of the variable a, which is saved in the pointer. So in here, from 8 bytes later, we would have this address, and the content of this address in here would be 15. Just work with it and watch the lecture again and again, and I hope it all makes sense and it wasn't confusing or boring. And if you have any question, please let me know.